Good day, everyone. Now let's solve the last practice question from the last class. When two objects P and Q are supplied with the same quantity of heat, the temperature change in P is observed to be twice that of Q. The mass of P is half that of Q. The ratio of the specific heat capacity of P to Q is what? Now, this last statement is what is telling us what to do. The question wants us to find the ratio of the specific heat capacity of P to Q. Now, what does that mean? It means that we have to get the specific heat capacity of P, get the specific heat capacity of Q, and then find the ratio of specific heat capacity of P to Q. Now, let us try to bring out some of the parameters that we have in the question, and then we calculate the specific heat capacity of P, we calculate the specific heat capacity of Q, then we finally find the ratio. Now, when two objects P and Q, let us say that we have P here, then we have Q here. Now, when two objects P and Q are supplied with the same quantity of heat, the same quantity of heat is supplied to both P and Q. Let us represent the quantity of heat supplied to both P and Q by Q. So the quantity of heat supplied is Q, and I'm putting Q. Here also is going to be Q. Do you know why it is QQ? Because it is the same quantity of heat that is being supplied to both of them. The same quantity of heat. So let us continue with the question. The temperature change in P is observed to be twice that of Q. The temperature change in P is observed to be twice that of Q. That is, it is 2 times that of Q. So once you know the temperature of Q, then you multiply it by 2 to get the temperature of P, because the temperature of P is 2 times, it's twice that of Q. So let us use something to represent the temperature of, a variable to represent the temperature of Q, then we multiply that variable by 2 to know the temperature of what? Of P. So let's say the temperature change in Q is T. Let us say it is T, like this. Then the temperature change in P is twice, it's 2 times the temperature change in Q. So I'm going to say temperature change here is going to be 2T. 2T, because it's twice that of Q. Now let us continue the question. The mass of P is half that of Q. The mass of P is half that of Q. So which means that when you know the mass of Q, you will divide it by 2 to know the mass of P, because the mass of P is half that of Q. So let's say the mass of Q is M. So we can say M here. Let the mass of Q be M. Then the mass of P will be half, is half. The question says half that of Q. So I'm going to say the mass of P will now be M over 2. So the mass here will be M over 2. So the ratio of the specific heat capacity of P to Q is what? Now, meaning that the next thing to do is to calculate the specific heat capacity of each of P and Q. Then finally, when we get the specific capacity of each one, then we find the ratio. Now, remember that we have a formula that we normally use. And from that formula, we can make the specific heat capacity the subject of the formula. Then we can find the specific heat capacity of each one first. Now, what is that formula? Q is equals to mc delta T. So let us make specific heat capacity the subject of the formula. From that same formula, then we substitute the parameter of each one to get the specific heat capacity of each one first. Then finally we find the ratio and we get our answer. So what am I saying? I'm saying that we know that Q is equals to MC delta T, right? Now, we are looking for specific capacity of each one. But this formula, let us make the specific capacity the subject of the formula first, because it is the one we are looking for this and for this. So here, to get specific capacity, I will divide both sides by M delta T, because what is disturbing this C? They are M and delta T. So I want C to stay alone. That is what it's meant by making it the subject of the formula. So I'm going to say this one, and I'm not going to waste time. So I will divide this by M delta T, divide this by M delta T. So this cancel this cancel this. So my C is now alone. My C is now alone. So I will say my C is equals to what? Q over M delta T. That is, this is the formula that I'm going to use to calculate the specific heat capacity of this, and the same formula that I'm going to use to calculate the specific capacity of this. Then when I'm done, I will now find the ratio. Now let us find the specific heat capacity of P. Now it means that Q, what is the value of Q for P? It is still this Q, right? What is the value of M? It is M over 2. What is the value of delta T? Temperature rise, change. It is 2T. That is what we are going to substitute to get the specific capacity of this. The same thing, when we are done, we substitute this into this to get the specific capacity of this. Then finally, we find the ratio for P and Q. So what I'm saying is this. Here, specific capacity of P first. So that is going to give us, we are trying to manage the space. Q is still Q. We are substituting this here now. Q is still Q, so I'm going to put Q over, what is our M? You know, this is our normal formula, but we are putting the parameter as gotten from the question into this. So our M is for P is M over 2. So I'm going to say M over 2. Then multiply by temperature rise for P is 2T. 2T. So what is going to be my C here for P? My C, let me write it here. My C is going to be equals to, remember, we can cancel this. 2 here, we cancel this 2, right? So, or let us write it here so it can be clear. So C will be equals to Q over, so what is left here is M times T, that's over MT. Remember these 2, I already cancelled these 2 here. So that is for P, specific capacity of P. You have calculated. The same thing. Now let's calculate the specific capacity of Q using this same formula. So specific capacity of Q will now be C is equals to, now remember, what is this Q for this? It is still Q because it's the same quantity of it. So my Q, I'll put it here, over, what is M for Q? M is still M. So I'll put M. So what is changing, temperature change for Q? It is what? It is T, right? So we put T here. So it means that this is, here there's nothing we can cancel again. So this is the specific capacity of what? Q. But the question says that find the ratio of specific capacity of P towards Q. So this is the ratio now. Specific capacity of P. Remember, let me say CP, specific capacity of P, and specific capacity of Q now. So that would be CP ratio C what? CQ. And CP, after we have simplified, is this. So that's Q over MT ratio, because this is for specific capacity of P, ratio specific capacity of Q is also what? Is also Q over MT. Now we have done this. Ordinarily, somebody who is well grounded in mathematics would do this without turning this into fraction. But now let us do that let us express this in terms of fraction, because we know that the ratio can also be expressed in terms of fraction, right? So what I'm saying is this: if I say 2:3, I can write it like this: 2/3. Can you see? I can write it like this. So if I say this ratio this, I can also say this divided by this. That is what I want to do now. So let us do that. Here I'm going to say this, which is Q over MT ratio. This ratio I would say divided by what? Q over MT. So because of space, I'm going to simplify in front, which is going to be equals to, you see this, I'm going to say Q over MT, this one up. You see this division, I like changing it to this type of division so that people can understand what I'm doing. So this also, I'm going to put it like this: Q over MT. You see, but you should be able to know that these are fractions. So you can change the division to multiplication, and the fraction that is in this front, you turn it upside down. So what am I saying? So this is going to give us what? This is going to give us Q over MT. This we turn to times, but this one we turn upside down, which is going to be MT over Q. Can you see? Now Q can cancel Q, 1, 1. MT cancel also 1, 1. Or you see M cancel M we 1, M here 1. MT also cancel T, which is 1. So what are we going to have left? 1 times 1 is 1 over 1 times 1 is also 1. So we have 1 over 1. Remember the question said ratio. So we are going to turn this to, this is going to give us 1:1. Can you see? So that is the solution to this question. Now remember, just the question they can decide to say, what is the difference between the specific capacity of P and Q? See, find the specific capacity of P, find the specific capacity of Q, and subtract, because difference means subtraction. But in this case, they said, what is the ratio? Find the specific capacity of what? Find the specific capacity of P and that of Q, and find the ratio. Sometimes it may be the ratio of their mass that they will ask us to find. So we make mass the subject of the formula. We find the mass of P, we find the mass of Q, and then we find the ratio. So that is that. Just try to understand the question, bring out a parameter, and solve it like this. That is it. So that is the solution to the last question. Thank you.